Hey, hi. Now in this problem, we have a line shaft which has been driven by means of a motor which is placed vertically below it, and the pulley on the line shaft is 1.5 meters in diameter. Okay, and it has the belt tension of 5.4 and 1.8 kilonewtons on tight side and slack side respectively. Now both these tensions may be assumed to be vertical, and if the pulley is overhanging from the shaft, the distance of the center line of the pulley from the center line of the bearing being 400 millimeters. Now what we have to do is to find the diameter of the shaft. Alright, now what we are assuming is that the maximum allowable shear stress is 42 megapascals. Alright, so now what you have to think is, just imagine we have a pulley. Alright, so we have a pulley like this, and इसके ऊपर बेल्ट है और इसके नीचे भी एक पुली है which has been driven by a motor. अभी तुम लोग सोचो कि अगर ये मोटर घूम रहा है इस डायरेक्शन में, ठीक है, ये उसका शाफ्ट है, दिस इज मोटर शाफ्ट and this is our shaft, okay, of this problem. Now just imagine agar this is rotating clockwise, so this pulley is trying to pull this belt, isn't it? ये इसको खींच रहा है. So अगर ये इसको खींच रहा है तो naturally you can feel it कि यहाँ पे टेंशन ज़्यादा होगा. So let this be T1, and this tension on this side is T2. So this tension is called as tight side. क्यों? Because ये उसको खींच रहा है, because it is rotating in this direction. Now just assume कि अगर ये जो मोटर शाफ्ट है वो इस डायरेक्शन में घूमता था तो क्या होता था. अब वो यहाँ से खींचता था, अब वो इस साइड से खींचता था. So this would have been the tight side. Alright, so I hope you're getting what I'm trying to say. So direction matters. So whatever your direction is, उस हिसाब से tight side or slack side vary होगा, but it doesn't really matter in our problems. Alright, so now I want you to understand one really important concept, right? So let's say we have a pulley, and now let's say we have a pulley like this, and okay, so yes, so we have a pulley like this और ये अपना शाफ्ट है, ठीक है. अभी बेल्ट लगा हुआ है, अपने को पता है कि there is a motor down, यहाँ पे मोटर है, and it is driving this. So this is a motor pulley, this is motor shaft, and ये उसको घुमा रहा है, and there is a tension in the belt. Say if the motor is rotating in this direction, this would be our T1 and this would be our T2. Okay, अब तुम लोग सोचो कि यार अगर मेरे पास एक पुली है और उस पे एक बेल्ट है, this is the tension, say T1, and this is the tension, say T2. अब तुम लोग फील करो, अगर this weight, let's say ये वजन 100 न्यूटन से, and let's say ये वजन भी 100 न्यूटन से. Now when we say torque, now what is torque? Basically torque is nothing but the force. Now when we say force, that force is in tangential direction. It is force which is tangent 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 to the shaft or to the pulley, to a circular section. Now that force जो भी रहेगा, that should be tangential times the radius. Alright, times the radius. Now I want you to feel कि अगर ये दोनों equal रहता था, if T1 is equal to T2, if both are equal to 100 newtons, then what's going to happen? ये पुली घूमेगा ही नहीं, isn't it? ये पुली घूमेगा ही नहीं because वो equilibrium में दोनों का force equal है. So there is no tangential force. There is no tangential force. So if you want to calculate the tangential force, it's nothing but the difference between T1 and T2, isn't it? It's so simple. The difference. So what we'll say is my torque always should be equal to tension 1, let this be tension in tight side, and say T2, which is tension in slack side, multiplied by the radius. Okay, so let's see our problem and let's see how we can sort it out. So let's say we have this T1, which is equal to 5.4 kilonewtons, and then we have T2, which is equal to 1.8 kilonewtons. So what would be our torque? It's very simple. Now torque, as we discussed, कि torque is nothing but T1 minus T2. अभी अपना T1 is 5.4 minus T2, which is 1.8. So it would multiply this. Now this 5.4 minus this 1.8 would be our force in tangential direction. I hope you're getting what I'm trying to say. Now this multiplied by the radius. Now our radius is 1.5 is our diameter, so the radius would be 0.75 meters, which would be 750 millimeters. So this would be something around, okay, I'll calculate. Alright, I'll see. The value is 2700 into 10 raised to 3. This is Newton into millimeters. Okay, so basically हमने क्या किया, T1 minus T2 किया multiplied by R, और उसका logic क्या है वो समझो. So I hope you're getting, and if you multiply this by R, you will get the torque. Now this is our torque, which has been experienced by our shaft. Alright, it's so simple. Now there's one more concept, and that concept says कि the same concept which we did in the last video. Now what it said was like my torque is equal to pi by 16 into Fs into d cube. Okay, and torque is also equal to or else you can just say that T1 by T2 is equal to e raised to mu theta. Anyways, we'll come back to it later जब ये problem हम solve करेंगे. But for now, you have to understand that torque is the difference between T1 and T2 multiplied with the radius, जो हमने पहले बहुत बार किया है. But anyways, so once you get the point is that once you get torque, now I'm also interested कि यार मेरा bending moment क्या होगा. So in this case it's pretty simple. You have this weight. Now this weight is nothing. I want you to feel कि अपना पुली है, उस पे tension है. So there is a tension T1, there is a tension T2. Okay, so this is T1 and this is T2. अब ये कहाँ पे act हो रहा है? This is acting in this direction. So basically वो force जो tension है वो नीचे act हो रहा है. So वो जो नीचे act force हो रहा है, that multiplied by this distance should give us the bending moment. So I hope you're getting like this force. If say for example I want to know what is the bending moment at this section, then I'll say whatever the force is multiplied by this distance, and I'll get the bending moment at this distance. So I hope you can feel that the maximum bending moment would be this force times this distance, because this is the maximum distance that is achievable. So this is the maximum, this would be the maximum bending moment, and it would be equal to my T1 जो नीचे आ रहा है और T2 जो नीचे आ रहा है प्लस मेरे पुली का खुद का वेट. But in this problem we don't have pulley ka weight, so for now this force which is acting downwards is nothing but T1 plus T2. Okay, so we know what a T1 is, we know what a T2 is, so let's add it. And so I hope you're getting. So my bending moment, let's say my bending moment is M. Now this M is equal to mera force. So my force is T1 plus T2, so it is 5.4. so let's say 5400 newtons mein minus 1800. So this was kilonewton, we just converted into newtons by multiplying it by 1000. So this is I'm sorry, this is plus. ये दोनों फोर्स नीचे के डायरेक्शन में जा रहा है, so that's the reason दोनों को ऐड किया है. Now this force which is acting downwards, if I multiply this by the distance, so that distance is 400, so this force into 400 is the maximum bending moment. So the maximum bending moment, if you calculate this, would be 2880 into 10 raised to 3. अब इसका यूनिट रहेगा न्यूटन इंटू मिलीमीटर्स. ओके, सो इट्स प्रीटी सिंपल. टॉर्क निकाला, मोमेंट निकाला. नाउ देयर इज अ वेरी इंपॉर्टेंट पॉइंट विच आई एम टेलिंग नाउ. फर्स्ट, अगर अपने को खाली अगर अपने शाफ्ट पे खाली टॉर्क आ रहा है तो हम फॉर्मूला यूज करेंगे पाई बाई 16 इंटू एफ एस इंटू डी क्यूब. ठीक है, इससे हमको डी की वैल्यू मिलेगी. अगर हमारे टॉर्क पे खाली बेंडिंग मोमेंट आ रहा है तो हम बोलेंगे कि दिस बेंडिंग मोमेंट इज इक्वल टू पाई बाई 32 इंटू एफ बी विच इज बेंडिंग स्ट्रेस इंटू डी क्यूब. इससे हमको डी की वैल्यू मिलेगी. बट इन दिस प्रॉब्लम टॉर्क भी आ रहा है और मोमेंट भी आ रहा है, दोनों एक साथ आ रहा है. सो इन दिस सिचुएशन व्हाट वी डू is there is a term which is called as equivalent torque. It is TE. It's pretty simple. Now this TE is equal to under root of जो भी तुम्हारा मोमेंट आया है, मैक्सिमम बेंडिंग मोमेंट आया है, उसका स्क्वायर प्लस जो भी तुम्हारा मैक्सिमम टॉर्क आया है उसका स्क्वायर. ओके, सो इट्स प्रीटी सिंपल. नाउ इसकी जो भी, सो लेट्स सब्स्टिट्यूट इट फर्स्ट. नाउ अपना बेंडिंग मोमेंट मैक्सिमम क्या है? We just now calculated it's this value. Now this is our maximum bending moment, so we can just put it in. So it is under root of 2880 into 10 raised to 3 का square. Now what is our torque? वो भी अपन ने calculate किया है. So the torque which is acting in the shaft is this value, is this value. So it's 277 into 10 raised to 3. So it's 277 into 10 raised to 3 उसका square. So इसका जो भी value आएगा, say for example इसका value है I don't know what the value is, say it's an apple. So this apple should be equal to pi by 16 into fs into d cube. Now इसमें से हमको d का वैल्यू मिलेगा. Okay, so it's pretty simple. T is equal to बेंडिंग मोमेंट का स्क्वायर प्लस टॉर्क का स्क्वायर. बेंडिंग मोमेंट निकाला इसमें डालो, टॉर्क निकाला इसमें डालो, उसका जो भी वैल्यू आएगा, से इट्स एप्पल. नाउ दिस एप्पल शुड बी इक्वल टू पाई बाय 16 इंटू एफ एस इंटू डी क्यूब. सो from this equation हमको एक d की value मिलेगी, and that value in our case is 78 millimeters. So this is equal to, let's say, 80 mm. Okay, no problem. Now there's so as there's a term which is called as equivalent torque, there is also a term which is called as equivalent moment. Now this is nothing but 0.5 times m plus te. Okay, so te is nothing but this. Okay, I mean t is nothing but this, and we know the value of t. Just put it in, plug it in. Now this m is nothing but this. Okay, so you'll get some value of 65 millimeters. Now this 65 millimeters is the diameter of the shaft. Like, I mean, this value is equal to this whole value जो भी तुम्हारा आंसर आएगा is equal to pi by 32 into fb into d cube. इसमें से तुमको एक d की वैल्यू मिलेगी. Now this d की वैल्यू is 65 millimeters if you calculate. So the question is कि हम कौन सा diameter select करें. It's pretty simple. जो भी बड़ा है वो सिलेक्ट करो. So in our case, this diameter जो हमने equivalent torque से निकाला था is bigger than the diameter जो equivalent bending moment से निकाला था. So we will select this value. So it's pretty simple. There's nothing difficult, and I hope you're getting. So see you in the next video. Alright, see you. Bye bye.